What if I told you that selfies were made popular by the US government to help build a facial recognition database? Cool story, bro? So what? You'd ask me to prove it, right? But what does it really mean to prove something? Well, let's look at a dictionary. A proof is the cogency of evidence that compels acceptance by the mind of a truth or fact. Well, no, that doesn't work. It's not good enough for maths. Because in maths, we need to be beyond doubt. Beyond reason. Well, within reason, but beyond doubt. Later we'll show you in another video how exactly to do this. But for now, let's focus on why we prove. In maths, every statement, everything that we know, is based on everything else. So we have this huge tree where at the bottom we have these statements, or these things that we agree on, called axioms. And then, based on those, we can prove things. And then we use those to prove that other things are true, and this continues on and on. This is where being absolutely sure that something is true, all the time, without doubt, is so important. Because as soon as there might even be a sliver of a doubt that something is not always true, then it falls down, it breaks, and then everything that was based on that also falls. And then this cascades up the tree. Everything that we thought was true becomes false. Everything dies. Anyway, proofs are important. But do we have to prove everything? I mean, aren't some things just obvious? Like, isn't it obvious that 2 plus 2 is 4? Well, actually it turns out it's not always. Truths or statements that are true but not obvious, and other things that are obvious or seem obvious, but aren't true. So what are some of these cool things in maths? Like, cool. Well, this thing called the Banach-Tarski paradox, which says you can take a sphere, a solid ball, and you can break it up into a finite number of pieces, and then assemble them into 2 identical solid spheres of the same size as the original. Basically, we've doubled the volume. What? Well, how does that work? Well, it's a bit too complicated, but the thing is, we've used true solid logic to prove this. Even though this works only for mathematically specific spheres, and not in real life, it still shows a lot of really deep, important things about how the universe works. There are so many more cool things and so many more unintuitive things that we would love to put in this video. There's things like infinite divergent sums, flipping spheres, things that require an infinite amount of paint to paint. But we can fill it with a finite volume. Okay, this is way too cool. So if you take the function y equals 1 over x, you cut it off. You take the rest of it and you rotate it around the x-axis, you'll get this big cone that extends off to infinity. But this has infinite surface area, but it has a finite volume. Pi, the unrepeating infinite decimal that we all know about, has a formula. But this guy called Ramanujan came up with this formula just out of the blue. And what? How did he come up with these numbers? This is the ratio between the circumference and the diameter. How does it exactly equal 1 over pi? There are the same number of points in this little circle as there are in the universe. And if you've got 6 people at a party, and there are people who like each other, or hate each other with a passion, then no matter how these are arranged, there are either 3 people who all hate each other with a passion and want to kill each other, or 3 people who really like each other and have friends. The awesome thing about this is that out of this total randomness, we have order and patterns. But what if we didn't prove things? Well, for starters, we'd be still trying to solve equations that cannot be solved. We might, for example, think that all horses are the same color, and even patterns that look obvious won't be true. Proving is sort of like an art. Every step, every move, every theorem that we come up as a building block, with our pens and pencils, with our computers, we are proving parts of the universe. In a way, when we write proofs, there is a certain beauty, elegance, some perfection that we strive for. It will be a strange concept to you at first, but with practice and exposure, you'll become very good at it. Trust us, we've been there. Thank you for watching this video. made by NZMOSA in collaboration with the University of Auckland. Have a look at our next video for how to actually write proofs. Thank you. We hope to see you another day.